All right. Let's see. Okay, so I would like to cover a new topic today, just to familiarize. Uh, so there are two types of linked lists. Um, so we're going to cover the second one. I've done the first one before, so yeah. Okay, so we're going to talk about doubly linked list today. Um, Here was a linked list problem that I solved yesterday. I'm not going to do that today. There's no question to solve today. It's just learning something new, right? So I'll come here. I think I should have left some resources in the description, but I did not. So there are some places you can learn about doubly linked lists. So I'll link those in the description now. So here, let me put that in the description. Doubly linked list. So I'll put resources. Yeah, so here are some resources for doubly linked list. This is a YouTube channel. There is this article on Geeks for Greeks, which is really nice to learn about doubly linked lists. So I'll put that here as well. I think that's about it. So with this, we can learn about doubly linked lists. Before I jump into doubly linked lists, I'd like to explain briefly what linked lists are, right? So okay, linked lists are basically so let me see. Linked lists are basically a type of data structure, right? Where items are arranged in order, in a certain order, right? And basically they are. Oh, this is linked list. I want doubly linked list. Oh, so I left the wrong link. So let me edit this quickly before I go back to link this. Yeah, I can leave that as well and put this here too. Okay, so linked list basically is a data structure, right? Where items are arranged in a certain order, right? So, and items within a linked list are called nodes, right? So we'll have nodes like this. So here is a representation of, an example of a linked list, right? So here we have another node. Sorry, my drawing is a bit bad. So we'll have these are nodes, right? These are nodes in the linked list. This linked list here, I'll call it X. Now, or let me call it list like this, list L, right? So I mean, this list here is just a representation of items arranged in a certain order, right? And each item in a linked list is called a node, right? Here, this item here, right? This here is an example of a node, right? This is a node, and here is another node, and each node has a property, right? And those properties are the value of the node. So usually you will see there's no way that just happened. Bad network. Okay. So like I was saying, right, every item in a node, right, each item in a node is known as each item in a linked list is known as a node, and each node has certain properties, right? The node and the next value, usually from the start it is none. Now why do we do this next? This next simply represents like a slot to which we'll add a new node in our linked list, right? So let's say this is our linked list, and our linked list has, let me remove let me keep this here, right? Here's our linked list. Imagine we wanted to add another value to this linked list here. I'll call this 2 and 3, right? Let's say we want to add a new node, right, 4 to this linked list. Now each node will have a next value set to none, so I'll put this here as none. Now the last item in the linked list is usually known as the tail of the linked list, so the tail will also have a none value right at the end. Now this none is simply the next value of this node. So now for us to add a new node to our linked list, we simply represent the we simply replace the node that has a none value, right, a next value set to none, with our new node that we want to introduce to the linked list. So here's what we need to do. We simply take this, right, we remove this, and then we'll just grab this from here and then push it all the way to the end of our linked list, and this is how our linked list will look at the end of the day, right? So we'll have the last node with its none value. Anytime we want to add a new value to the linked list, we will simply go from the beginning all the way to the end, or all the way to the point where there is a node that has a next value set to none, and that is the point where we insert the item in the node in the linked list. Now insertion of an item in a linked list, right, at the end of an item in a linked list is done in O of n time complexity, right? O of n. While in arrays, right, it is done in constant time because we are just inserting at the end of the array. And why is this so, right? Why is it so this is array, and this is linked list. Now I'll call this insertion like this. Now why is it like this? Well, the reason why it is faster to insert an item in arrays than in linked lists is because in arrays we know the position of each item. In other words, each item in an array, right, 1 2 3 like this, has a certain position called indexes. So this will appear, this one here will appear at index 0, this 2 will be at index 1, and this will be at index 2. Now we'll know the length of this array. The length of this array will simply be equal to 3, and then we know to insert an item to this array, we can use, we can increment our array by 1. So we can do something like this. We can say, okay, this array here, there's a built-in method to do this, but I was just going to explain the manual way. We can simply increase the length of our array by adding a 0 here, right? But to add 0 again is still adding an item at the end. So we can simply use the let's say in Python we can use a push method, right? A an append method to add an item to the array, and that is done in constant time, right? So it's simply 3, and then the array is like this, and then we'll do dot append let's say 4, right? This will add 4 to our array. And how is this done? This will simply increase the size of our array by just adding 1 to the length, right? Then we know our array will become something like this: 1 2 3, and then there is a free slot for us to insert our new value to it, which is 4 here. So this will be done in constant time. We don't need to know how many items are in the array already, or how many items exist in the array for us to add a new item to the array. We simply need to know the size of the array, or whether the array even exists, right? And then we just insert our item at that position, which is at the end. And the same thing is for removing an item from the end of the array, right? We know the last item of the array is at index 2. So to remove an item from the array, we simply remove the item at index 2, which is the last item in the array. So here is how this operation ends up being, O of n time complexity, O of 1, which is a constant time complexity operation. The same thing goes, but in the case of linked list, removing an item is simply not easy, right? Because we don't have indexes in linked list. So we need to go from the beginning all the way to the point where we find a node that has a next value set to none. Then we'll know that node is simply the last node in the linked list, and then we can remove that node from the linked list. So which is why if we had 10 nodes in our linked list, then we have to iterate 10 times to get to the last item before we remove that last item from the linked list. So removing an item from a linked list takes O of n time complexity, right? Inserting an item at the end too, right? Removing from the end is setting an item in a linked list to will take O of n time. Meanwhile, in arrays, it is constant time complexity. So removing an item from the beginning of a linked list, right? That will be done in O of 1, right? Time complexity, because this is a constant time complexity. We always have access to the head of our linked list, right? Our linked list always has to begin from the head. So that's about it for, and this type of linked list is known as singly linked list. And I would like to cover a new type of linked list, which is doubly linked list. And let me see. So doubly linked list, doubly linked list is what I'm going to cover today. And let's see what doubly linked lists are. So I left some links in the description that you can use to get those information, any information on doubly linked lists. So you shouldn't be too lost when you're learning about doubly linked lists. There's even a channel where I learned doubly linked lists, which is really awesome. Okay, so let's see. Let's read a bit about doubly linked list. So a doubly linked list is a more complex data structure than a singly linked list, but it offers several advantages. The main advantage of a doubly linked list is that it allows for efficient traversal of the linked list in both directions. This is because each node in the list contains a pointer to the previous node and a pointer to the next node. This allows for quick and easy insertion and deletion of the nodes from the list, as well as efficient traversal of the list in both directions. So basically, in the case of doubly linked list, right, the nodes have pointers in both direction. Now, like I said before, so I still, thank God, thankfully I did not delete this. So in the case of a doubly linked list, we'll have a new property called previous, right? Now this previous here will point to the previous pointer, previous node in the list. So every node will have a previous value, right? So I'll delete everything. Let me erase everything first of all, in order for me to explain this. So I'll just remove here. So let's take this node here, and I will do this. Say okay. So here is my linked list, right? And this is singly linked list, right? So I'll put 1, 2, and then 3 here. So this will be none, right? None. Now, in the case of a doubly linked list, each node has a new property, right, which is called the previous property. So every node points in both direction. So the first node here will have a none because it's not pointing at anything. This node here will have its previous property set to the first node, and the first node will have its next property pointing to the second node, and so on, right? So the same thing will happen here. So this is the previous, this is the previous, this is the previous, this is the previous, this is also the previous of this node. So each node in the linked list has a previous value, right, or a previous property pointing to the previous node before it, or the node before it. So yeah, so they will have nodes in both directions. So if we were to represent this node here, right, this node in a representational form would look like this. So this node will be an instance of a node class, and this node class will look something like this. This node class will have a previous value, right, previous set to none. The value of the node itself is going to be equal to 1, and the next property will be none at first, until we introduce this new node into our linked list, right? Then we'll replace the none value here with this new node, and this new node itself will have all of these properties, right? So but instead of this node having its previous value set to none, the previous value of this node will be set to this node here, right? And then we can simply say, okay, so this next value will be gone, it will not be none, it will now be a new node set to, so I'll put it like this. This will be a new node set, previous value should be equal to the previous value here should be equal to 2. Sorry, the previous should be this node here. I'll represent it with this color, with this blue color node, and the next its next value will be so I'll represent this, the value of this node here, right, which is the second node we want to introduce, will be equal to 2, and its next, the next here, next will be none for now. Next will be none, like this. So, and then we'll continue chaining each item in the node, in the linked list, right, to form a doubly linked list. So we are going in both direction. We are setting the previous to the previous node, and then the next to the next node, right? So I've done some practice here, but I'll still go over this again, and then we'll implement this from scratch, right? So you can see we are going to cover how to add an item in a doubly linked list, right? We are going to cover that. We are also going to cover how to prepend an item in a linked list, adding an item in front of a linked list, and also doubly linked list, sorry, and then also how to print every item in a doubly linked list. So I'm going to delete this again, and then we'll do this from scratch. Okay, let me just create a doubly linked list folder. I'll call this doubly linked list. So let me create a new folder here. I'll call this doubly linked list. So new folder. There's a message in the chat. Hello Kumar, nice to have you in the chat. So let's do this. I'll say doubly linked list. Doubly linked list just means two linked lists. Double linked list. So I'll say double dash linked dash list. So yeah, that's it. So I'll create a file called basics, right? So to cover the basic stuff, basics here. So we know our doubly linked list has certain properties, which is the previous, like this, the value, and then the next. So here this article explains that as well. So what is a doubly linked list? A doubly linked list is a data structure that consists of a set of nodes, each of which contains a value and two pointers, one pointing to the previous node in the list and one pointing to the next node in the list. This allows for efficient traversal of the list in both directions, so making it suitable for applications where frequent insertion and deletion is required. So yeah, so we can use a doubly linked list for this kind of operation. So here is a representation of a doubly linked list. So there's this thing here, which is what I want to cover now. So we can just do that. We'll cover traversing a linked list and a doubly linked list, creating a doubly linked list first of all. Now, the nodes in a doubly linked list have three properties, which is the previous, the next, and the value of the node. So I'll create a class called node. So I'll call this a node class, right? Oh, sorry, this is not so this is going to be a node class, a class called node, right? And then I will create three properties for this node. First of all, we will need to instantiate this node, right? We'll need to instantiate this node, and when we are instantiating the node, we simply give it a value. So I'll set this value here, right? And then I'll say self dot previous, which is the previous value of the node, right, or the previous pointer of that node, will be none at first, because I mean the first node does not point to anything, right? So and then I would say so doubly linked lists and singly linked lists are similar, right, in terms of this basic insertion and creation. So the only difference here is that we introduce the previous properties. So we'll have a self dot value, right? I'll call this self dot val. Let me just leave it like that, or you know what, let me type it all out. So this will be value here, self dot value, and then we'll set this to be the value of the value we pass in the instantiation phase, right? So when we instantiate this node class, we'll pass it a value, so which is the value we set here. And then the next property of this node, right, will be none at first. Now let's pass on to creating our doubly linked list class. So I'll call this I'll say Doubly, for short form for doubly. I'll call this linked list. So here's our doubly linked list, and here's what I'm going to do. So I'll define a function called so we will need to instantiate this doubly linked list, right? So to instantiate it, we'll simply do define init, so the constructor function. Now instantiating this doubly linked list class does not require us to pass it a value, right? So we simply need to create, it's just like creating an empty array by just setting the open bracket, right? So we don't pass it a value immediately until we have the requirement to, right? So here is what we need to do. So we'll say the head, right? We always have a head in our linked list, and we'll set this head to none, right? So this head is nothing at first. Like I said, it's just like creating an empty array, right? Let's say we do this, we say names, right? Names is equal to an empty array. This is allowed, right? It doesn't mean we always have to add a value to our array from the start. So which is why we can instantiate, we can create an instance of our doubly linked list without having to pass it any value to begin with. So now the next thing we want to do is to add items to our linked list, right? Add items such that, you know, each item has these three properties: the previous property, the value property, and then the next property. Now, to add an item to our linked list, there are certain positions where each item will appear in the linked list. Now, the first item in our linked list, or in our doubly linked list in this case, will be the head, right? And for us to set the head of the linked list, we need to first of all check if there already exists a head before we begin to add a new head to our linked list. So we'll define a function called add node as usual, right? I use the same thing in adding in a singly linked list, which is this. So you can have access to this in the GitHub repo linked in the description. So now when we are adding a node, right, we want to add a node with a value, right? Because our node will always have a value. Now this means we want to add a new node to our linked list, and adding a new node simply means adding instances, or an instance of a node into our linked list. So we need to create a new node, set it to the an instance of our node. So I'll call the node class here and pass it this value. Now this value could be our head if we don't have any head. So let's first of all check if there's a head. So I'll say if not self dot head, right? If not self dot head, then we want to add a new head. So we'll say self dot head should be equal to new node, and then we return. Now one thing you might be curious about is why don't we have why don't we set all the properties here, self dot head dot value and then so on, right? So the reason why I didn't do that is because the new node, this node class here, already set those properties for me. So the previous value of the head will simply be none. The value will be this value when we call this function here, add node, and then the next will set to null. So we don't need to do any extra operations here. Now let's say we added the head, right, and then we want to add a new node to our linked list, but this time around the linked list already has a head, right? So we simply need to add the node at the end. So let me show you what I mean by that. So let's say I would erase everything here. Sorry. Let's say we have a linked list like this. So our linked list is beginning to take shape, right? So we added one, right? Let's say we added one will have, you know, the previous property here, I'll call this previous. So let me do this properly. The previous property here, this is going to be equal to none, and then the next property here as well will be none, right? Now how do we add a new item to our linked list? Well, since our linked list is doubly linked list, right, we want to set the next property of this node, right? We want to see, so the next property or any node in our linked list that has a next property set to none means that node is the last node in our linked list. And in this case, even though this is our head node, right, it is also the last node because it is the only node in our linked list. So we simply need to take our new linked list, right, replace this none value, right, with our new linked list by attaching it like this. So this will be 2, right, and then the previous value of this node here will be set to this new node, and this new node also has a next property set to none. But this time around, since we are working with a doubly linked list, this node also has a previous property that will be set to this previous node here, which is going to be equal to prev, right? This is the previous value of this node here. So I'm not going to add this, but I'm just indicating that this is the previous node, right? This is the previous node of this node. Now let's say we want to add a new node again, which is 3, right? This 3 again will have a next property set to none, and then we'll set this here also to none, right? This is the previous as well. So now for us to add this new node here to our linked list, right, we need to know where we should add it, right? And for us, how do we determine where to add a new node? It's simply when we see a node in our linked list that has its next property set to none. So in this case, we are going to add this new node here, right? Let me represent it with a different color so that it is easy to understand. So I'll set this to 3, right? 3 will have none, and then previous will be, nothing. So this will also be none as well. So when we instantiate the node class, right? So how do we know where to insert this new node, right? This node of 3. So for us to be able to know that, we need to find a node in our linked list that has its next value set to none. In other words, we need to start checking every node in the linked list until we find a node that has a next value set to none. Now how do we do that? Well, to do that, we simply need to start from the beginning of the linked list, which is checking from the head towards the point where we find a node that has a next value set to none, right? So I'll remove this. I'll simply erase this part here, right? And then so we'll run a loop that starts from the beginning. We check this place, right? Does this node here have a next value set to none? No, this node's next value is this node here. So we'll check this node again. Does this node has a next value set to none? Yes, this node has a next value set to none. So we simply take this entire node, or this new node that we just instantiated, and add it and replace the none value of this node to this new node here, right? So I'll remove all of this. And erase this part here, and then take this node like this, and then add it to the end of this node. So we'll have our new node set like this. So here's how we can add an item to the end of our linked list. Now this is not the end. After setting the next value of this node to this new node, right, to this new node, the previous value of this node here has to change, right? It's no longer going to be none. Instead, it will point to this new node. So I just erase the none and set it to our new node, and that's what will happen every time we try to insert a new node into our linked list. So let's go ahead and implement that. So for us to do that, first of all, we need to take the head, right? I'll take a copy of the head. I'll set it to current node, right? I'll call this current node set to self.head. As usual, this is the same way we insert an item in a singly linked list. So we take the current node. Now we'll need to run a loop to traverse the node, right? And traversing the node is simply resetting the current node to the next node until we reach a point where the current node's next value is none, or we reach the tail of our linked list. So we'll say while the current node has a next value, right? While the current node dot next, or you can say is not none, right? This is also valid, but I like to keep this short, right? This also means while the current node's value is not falsy, right? So we'll say we'll first of all set the current node to the next node, right? Current node should be equal to the current node dot next, right? So in every iteration, we will do this. We'll set the current node to the next node, like I said here. So traversing will simply mean, okay, we start at this point, right? We'll start at this point. Let's say this is our current node. I'll put this like this, or let me represent it with this, with another color. I'll represent it with a white color and maybe have a blue fill in it. I don't know why this is not filling it up, but anyways, that did not work. But let's say this is our current node, right? We set this dot here to our current node. Now for us to traverse this node, right, we simply need to be changing the position of our current node. And by changing the position, we simply need to move this node here to this point. And for us to move this node to this point, we simply need to take its current value, right? We simply need to take the current point where it is and set it to the next of this current point. So next of the head is this 2 here, so which means we have to move this. Will no longer be equal to the head but equal to the next node, right? Which is what I did here. So I took the current node, right, the current node, which is the head at this point, and set it to the next node. So the value here is no longer head but the second node, in case there is, right? And in our case here we have 2. So when we set this node here to the next node, it means we are changing this value here to the next node, which is 3. So this will move to this point until where we reach the point where the next value is equal to none. Then is equal to none, like this. Then we can now set that value or the next for that particular node to our new node that we want to insert in the linked list. So here is what we need to do. So we iterate each time until where we get to the point where the next value of that node is none. Then we can do this. We can say current node dot next will be equal to our new node. Now we've set the next value of this node here to our new node. Now our new node also has a previous value that should be set to the next node. So we simply need to do this. We simply need to take the new node, right? I'll say new node dot next. Sorry, new node dot previous, not next anymore. Dot previous should be equal to our current node, right? So the previous of this node should be equal to our current node. And this is how you insert an item in a linked list, right? So we will need to also know how to print the items in the linked list, or in the doubly linked list. Sorry for saying linked list. So to print the items in a doubly linked list, we simply need to define a function. I'll define this function called print nodes, right? Print nodes. And this is a function. It will not take any parameters because we are still using it as part of our linked list class, right? So we'll do the same thing again. We'll say current node will be set to the current head that we have, self.head, right? This is the head of our linked list. And then the printing of nodes in a linked list is the same as printing of nodes in in a doubly linked list is the same as splitting of nodes in a singly linked list. So they are very similar, right? So let me refresh this page again. Okay, so there's nothing there. All right, so let's see how we can do this. So after setting, we traverse the nodes. So I'll say while current node, right? So we just print the current node's value. So current node dot value, right? So current node dot value. I think I set it to value like this, and then I'll just add some arrow to connect every node, right? And then I'll set the current node to the next node. Current node should be equal to the current node dot next, like this. So here's how we'll print every node in a linked list, and I will go ahead and just print this out. So let's create an instance of our linked list, right? An easy way to do this, instead of me, so let me just, I'll say d list. I'll call this d list, which is doubly linked list. It's going to be an instance of the doubly linked list class, right? And then to add an item, we'll simply do d list dot add node, right? And then we'll add 1. So we'll do this for as many items as we want, but I don't want to, manually repeat everything. So I'll just call this num lists. I'll create an array of num lists here, and then set this to 4 3 2 3 6, right? Let's do it this way, and then I'll iterate through this num list to add. So for num in num list, right? For num in num list, we'll do d list dot add node num, right? So this is way simpler. So I can then go ahead and print out the nodes in our linked list. So I'll say d list dot print nodes. So here's all we need to do, and we'll see our doubly linked list in action. So here is it. We have our doubly linked list here. Now let's see, what else do we have to see? We need to know how to add an item in front of our doubly linked list, right? In front, or prepend an item in our doubly linked list. So how do we prepend an item? Well, we can simply define a function called prepend. Oh, before we do that, right? How do we? Okay, let me just finish this one first. Prepend node. I'll call this prepend node. Okay, so we want to add an item in front. Now, adding an item in front should be very straightforward, right? We know our first item in the linked list will be the head. So let me take my marker. I'll simply remove this node from here. It's too big, so let me remove this. I can increase the font size so that everything is properly displayed on the screen, right? Okay, so let's say we have these two nodes, right, and we want to add an item in front, right? Well, that should be straightforward, right? If we know our first item, to add an item in front of it, it means to simply replace the previous value here, right? We simply need to replace the previous value of the head of our original linked list to the new node. Let's say we want to add a 4 in front, right? Our 4 will also have a next value set to none, right? Set to none, and then a previous value here, right? Previous set to none as well. Now we simply need to take the head, right? The head of our linked list, right? Replace the previous value of this head to with our new new node that we want to add or prepend in our linked list, and then set the next value of this node to this head, or set this new node instead to our head, right? So I'll simply do that now. So here's what we need to do. So we'll simply take this node here, right? This node, oh come on, we'll simply need to remove Christ key. So we simply, let's create a new node. I'll create a new node. For this will have none as the next value, and the previous value here will be none as well. Now we'll replace this value here. This is our original head, right? I'll put OH for original head. We'll take the original head's previous value, right, and replace it with our new node that we want to introduce. So here's what we need to do. We'll simply erase all of this, and then we'll take this head here, right? We'll take this head here and move it to this point, right? We'll move it to this point. But before we move it, right, I mean after moving it, we'll then, I'll just bring this back here, take the head from this point here, the new node. So we are adding the new node to our linked list. So meaning we'll remove this none here, right? We'll remove this none from our linked list like this, and then take this node here and attach it, come on, and take this node here and attach it to our linked list head. So we'll attach it this way. So the previous value of our new node becomes the next value of our new node becomes our previous head, and our previous head's previous value becomes the new node, and this simply becomes our new node entirely, right? So that's how we'll add an item to our linked list. So I'll do that, and so let me show you that in code. So first of all, we need to instantiate our new list. So I'll say new node is simply going to be equal to, so when we are prepending, we want to prepend a value, right? So I'll pass this a value here, right, and set this value to our node dot value, right? So this is going to be our value, and then we will take this. So there's no iteration done here. This is just simple step by step. So we'll first of all set the previous value of our head, right? So I'll say self dot head, right, dot previous, right? The previous of this head should be equal to the new node, and then the new node dot next should be equal to our self dot head, and then we can set our new node now to the head. So self dot head should be equal to the new node. So here's the steps we need to take to append an item in front of our linked list. So let's try this out. I'll say the list the doubly linked list dot prepend node. I'll prepend 100, right? So when I print this node, right, 100 should appear in front of our linked list, which is this 100 here. So that's how we add an item in front, or in other words, prepend an item in our linked list, right? So and the next thing we can do with linked list is to the next thing we can do so the next thing we can do is to so reversing a linked list with a doubly linked list is quite easy than doing it in with a singly linked list. So here is how you can reverse a doubly linked list. So I'll define a function called reverse d list, right? Reverse d list. and we don't need any other parameters. So to reverse a doubly linked list, right, we know every linked list here, right, has a previous and next value, right? So to reverse is just simply going in this order, right, going from here to this part, right? Now, as you can see, I started from the last one going forward, right, which means we will iterate backward, right? We'll look from the back towards the front. Now, but how do we do this? How do we start iterating from the back when we don't know which exactly is the last item in the linked list? Well, here is what we need to do. We simply need to take a copy of our linked list going in that direction, right? And then we know at the end of the day, the last item we'll get to while copying every node in this linked list will be this one here. And then we'll start, iterating backwards by just setting this. So I'll do something like this. I'll say I'll iterate from this point towards the back. So I'll simply say I'll call this current node. Current node will start at this position here, right? Current node will be 4 at first, right? And then later on, current node will become 1, current node will become 2, like this, right, with every previous value and so on. So the previous value will be behind, towards the left, right? We can't say it now, but this has previous value. And then we'll take this current node, right, current node, and then iterate it backwards. So we iterate by simply setting the current node next. Instead of doing current node dot next, right, so say current node equal to current node dot previous, right, so that we can set it backwards and iterate towards the beginning of our original linked list. So let me show you that in code. So I'll say we'll have a current node set to the head of our linked list. So self.head, and then we'll say while the current node, right, so this is going to be two separate loops. We'll traverse forward, reaching the end of the node, and then start from the end towards the beginning. So we'll say while the current node, so we are iterating forward, right? So while the current node the next, right, while the current node has the next value, we want to set the current node, right, equal to the current node dot next. So this will help us reach the end of our linked list. Now we'll run another separate loop and say current node, right, this current node, and then we'll say current node while the current node, right, so while current node, we'll say current node should be equal to the current node dot previous, right, current node dot previous. I hope I wrote previous as prev. Okay, current node dot previous. So this will go from the very end towards the beginning, right? So, and that's all we need to do. I'll come back here, remove this. Now the reversal does not need any return, so we just run the reversal here, right? After prepending, right, we should have had our linked list like this. So so let me just do print here and then reverse the linked list. So I'll say dlist dot reverse dlist, and then print the dlist again, dlist dot print, like this, print the nodes. So here, I'm doing this to add some space between the first linked list, because we are using end here. There's no print of new line, so we can use this to print a new line and then start the reversal on this line here. So let's run this and see. I think there's something. Okay, so the reversal did not happen because reverse dlist, right? Is that what I said? So current node and next, we have two separate loops. Let me have a look at what I did before, since this is the first time I'm implementing the doubly linked list. So I must have missed something. Apparently I did not. So what happened? Oh, okay. So while oh god, sorry, my bad. While reversing the list, we need to print it, right? Because I mean we are printing it in the other direction. I completely forgot about that. So here's what we need to do. We need to print it each time. So we print the current node dot value, right? Dot value, and then we'll set this to, I'll put end here and set this to like this and like this. Okay, so this will help us reverse the linked list. We don't need to print the linked list again. So let's run this and bring this back. Now you can see 6 was at the end of the list, but now 6 is at the beginning. So that is how we can reverse a linked list by simply a doubly linked list by simply resetting. First of all, we need to create a copy of the linked list, of the doubly linked list going forward, and then printing backward with the current node set to the previous node each time. So that's about it, and that's just some basic stuff about doubly linked lists. Going forward, I'll begin to solve some doubly linked list questions as well. So I'll say git add git commit dash m, oh come on, doubly linked list basics. So here we go. So git push origin main. So that's about it. That's everything we need to know about doubly linked lists. How to reverse. So we saw how to add nodes to our doubly linked list, how to print each node, how to reverse or add item in front of the nodes. Adding item means adding at the back. So prepend and append. So we can call this append, and this is prepending here. So yeah, so that's about it. That's all we need to do to so this session has come to an end. Thanks to everyone who turned up, who was watching. I'll see you